I feel more comfortable here, which is why I'm making more mistakes, but I made plenty of mistakes at Yale too. What is this just going to stay here?
Is it going to stay there?
I don't know, it doesn't feel like it.
Sounds good.
Put it.
Get it out so I can turn it down a little bit. Tape it to its face.
Yeah, tape it to my face.
Otherwise it's going to feedback.
What does this? You've done it? All right, whatever.
Is it staying?
I feel a bit strange. Maybe I'll just use this thing.
You feel very strange.
Oh, I get it.
Come on, people. This is Damon Oehlman. You should applaud.
Don't applaud. This is the weirdest thing ever. Right, okay, so this is a presentation I gave at Yale, which was a lot of fun, the conference. It was a bit of a tough crowd because there was a lot of people there who liked types, very serious programmers, and there were some people who liked JavaScript. They didn't like types. So it's a bit of a tough crowd. Now, you guys being JavaScript people may not like types, but I'm going to hopefully convince you that there's some value in looking at them. And already we've heard people sort of say, hey, I'm interested in Flow, and I've used Elm and things like that. So I think you'll actually be a potentially receptive crowd. If not, have a beer afterwards, enjoy Jacob's talk.
No pressure.
So, we're going to do the demo? Yeah, why not? So let's just, if you want to bring up on your laptops, let's go to this one. Or your mobiles. That's right, you may not have a laptop with you. I'll add another tab. Rename Sid.js. I should have copied, that would have been better. Let's do this. So anonymous person, go to this tab. Let's kill a few people. Sorry.
What's your earlier?
That one. It's more fun with a demo, and the demo usually breaks, which is even more fun. A demo's not a demo unless it breaks. Got the URL for those interested. I don't know how Google Drive works on mobile. It could be pretty average. There's one person. Hello. Oh, it's Alex again. Thank you, mate. You worked last time. There's a few people in there. So, okay, there's a few people. We can come back and revisit that later. So type.js, this is how I felt about it. For a long time, I was writing JavaScript for a long time. Part-time since like 2000, and then kind of full-time since 2010. I made a decision in 2010 to sort of not be a full-stack developer doing .NET on the back end and JS on the front end, and just go full-stack JS. So Node.js on the back end, JavaScript on the front end. It was fairly obvious to me at that time that JavaScript was going to be just everywhere. So there was no point. And I could also see that there was going to be a genuine absence of people who understood JavaScript well enough that could, basically work in this space at a level that you could kind of trust. And it was also, as a language, it's pretty untrustworthy itself. So the trust level has to go to the executioner. That doesn't sound right. As opposed to the language. So this is how I felt. And then leading up to it, I think a few of you may know that I was originally in Brisbane, and I always enjoyed coming down to Sydney and visiting Sid.js, which was a much more engaging meetup than BrisJS. BrisJS was lovely, but we had like 20 people. So worst case scenario, if you want to do a talk to a small crowd, head to Brisbane. Good way to get started. And that's what I did. So anyway, when I came down, I was looking at joining Canva, and that's where I'm at now. I kind of knew they were using a type JavaScript variant there called Closure Compiler. And because I was opinionated, I'm still opinionated, because I knew that was there and I didn't really like the feel of it, I basically avoided joining, even though I liked what the company was doing. After a time, though, I felt Canva was the right place for me to be, so I ended up there. And after probably a period of 3 months, this is how I felt about type JavaScript. which I didn't believe. Like I couldn't actually work out why that was. No, I knew why it was. And there's been some good questions about, is it Stockholm Syndrome? We can go into that later. But it really does, on a code base that is in any way complicated, which certain code bases are, it does actually make a big difference. So what are we covering today? And I don't want to labour on too much. So just what Type.js is, to give you a bit of an intro. Whirlwind 2 are both Clojure Compiler and TypeScript. Clojure Compiler mainly because there's only a few people who use it, like Canva and a few others. Not going to do too much in TypeScript either because I feel like it's gotten a lot of press and publicity already. Like we've probably had a fair few TypeScript talks. But I do want to show Flow, which is Facebook's, not necessarily the new kid on the block, but it is, it is pretty new. So why would you use it? One of the big things you get is essentially guards in your code. Or explicit call-outs to where you need to guard your code. So if you say there's a particular area where you've got a potentially null value, which we all know we have nulls and undefineds, and that's something we see more often than not. So the GA people, how often do you see undefined is not a function? Is it a regular thing? Pretty regular? Well, this is where Type.js can kind of help you. And I guess like the opportunity that you all have at the start of your careers is to adopt patterns that essentially might stop you getting into trouble and then might stop your future customers getting into trouble as you go along. So this is a really good opportunity for you as people and developers moving into the future. Type system constructs. So we've got generally in more traditional languages, we've had good ways of expressing ways that we want our programs to look. JavaScript's always struggled a little bit. Prototypical inheritance is one thing that's hard to get your head around. Lots of other things, like Rob and I were talking about callbacks before, things that can mess with your head. Not all of those things are gone or necessarily handled, but there's some other things that you can add which are actually really useful. In terms of, like, not all of this is Type.js necessarily, even though TypeScript came along and introduced some concepts earlier. Like ES6 has progressed things quite significantly in terms of making things just feel a bit nicer. It's still JavaScript under the hood, but the way you're looking at things feels a bit more traditional or more used to what you might be seeing if you're coming from a different programming language background. Protection against type coercion. So again, I guess there's probably lots of people who've added a number and a string together and gotten an unusual result. Now I liken this to when I was in year 11 chemistry. The instruction we had from the chemistry teacher was, please mix hexene and sulfuric acid together in a test tube and, mix it up. And I was like, okay, that sounds good. So apparently the correct mixing technique is tap the test tube like this. I test tube it like this. I thusly ended up with sulfuric acid in my eye, 18 molar, very strong. Fun fact, eyes are basic, cancel out acid. That's great to know. But the quote that I remember my chemistry teacher saying is that those two things shouldn't have reacted. And type coercion is often like that, where you don't expect two things to do anything weird, but in that case, weird things happened. Mainly because I shook it rather than tapped it, but once again, it comes down to there wasn't a level of protection there that should have been there. I am responsible for my high school introducing safety glasses in chemistry. Type inference is a strong feature. So everything in JavaScript has a type, even though it may not be obvious. What happens in these tools is they often go through a type inference process to actually make some assertions about what the type is. So if you assign something a string, it'll go, that's a string. Sometimes you need to be more explicit to get that type information out, and we'll cover some examples. Reduce testing weight. If someone was going to say, what's the most compelling reason to use types in your JavaScript code, or probably any code, is that when you do it right, you can reduce the amount of testing that you have to write in your code by a significant degree. Like I still consider myself to be a good JavaScript programmer, but the result is to sufficiently guard myself against all of the use cases, I have to write this many tests. Add static typing and a compile kind of process to it, I can reduce that by some number. I think Rob could probably come up here and may even, I'm going to let you finish, have a discussion. And he's done some excellent property-based testing talks, but there are ways to, and that is a lot of load, because I think if you were to duck into some node modules, you would see some that are 4 lines long, but the test code, to test like that 4 lines is essentially possibly 250 lines worth of tests. And that's not something anyone enjoys writing. And that test coverage is probably not exhaustive. So let's have a bit of a look at Clojure compiler syntax. So I will race a bit over this, but I will use this syntax to cover some of the core concepts. So this is your ES6 class example. You've probably seen it before, like the ES6 class. And I think the key takeaway from the Clojure compiler syntax is just that it's all done in JS doc kind of format, which is actually kind of gets out of the way. It makes everything a bit more verbose, as in it takes a lot more characters, but in terms of being invasive to your code, it's not really. Like, your code is still just JavaScript, it just has these annotations in line. You can define something as an interface with this little interface guy up here, and this is what it looks like when you implement an interface. Enums are pretty useful. If you haven't been in language environments other than JavaScript, then an enum might be, or yes, they might feel a bit strange, but they're just generally a way of expressing like a limited number of possibilities for a thing. So here we're talking about a spinner style, and we said we've got a standard one and a fancy one. You should always have a standard and a fancy spinner. I just made that up then. And this is where you're using the enum. So you're basically saying, create spinner, it's a spinner style, and it's going to return a new spinner instance. And there we go. Type defs are probably the most useful feature in Clojure compiler, and that's where you define the kind of structure of a thing. They have equivalent concepts in TypeScript and Flow. It's just basically saying the shape of this thing is always going to have this. It's going to have a color option, it's going to have a mask, and it's going to have a spinner style. Once again, spinner styles are important. Generic types take more time to get your head around, but it's essentially, and in Clojure it's actually called a template type, but what it's saying is that this T that you pass is always used in any kind of expression. So if we're looking at the constructor, we're seeing the items, and we're passing in an array of T. So if we say we're going to create a new list of string, then we would have to give it string items in the list, otherwise it would be unhappy. So these things are like really powerful. TypeScript, going to race over it, but this is where you start to see that the definition style is quite different. You've got inline type kind of definitions, including and going a bit above what JavaScript's charter probably is, and that's things declaring private and read-only stuff, which is not generally what you get in JavaScript. But it's been powerful, and it is actually quite good. Like, there's no denying TypeScript's goodness. It's just, I think it's only going to take us so far. Interfaces, very simple. And the green thing means it works. The red thing means it doesn't. So, I mean, rather than me tell you why the red and the greens one don't work, can anyone see why the first red one doesn't work in terms of interface? It doesn't have...
Configure.
No, exactly. So that's right. The first implementation doesn't have the configure method, therefore it doesn't implement the interface correctly. You've got something, Josh? You know what the next one? Well, let's hear it.
It's the type of string is number.
That's right. So this first, like, the interface says that the configure method takes an opt that has a name, which is a string, and returns a void, but this other implementation has said, oh, name's a number. And it's like, sorry, mate, that's not okay. It's the bouncer which stops you coming in. Structural interfaces are very similar to these closure compiler type defs. So a good example that I immediately thought of is things like vector, and that's from a background of doing some map stuff, where I've got positions and bounding boxes and things like that. So here we can say, oh, we've got an add method which takes two vectors and returns the new vector. That one works, that one doesn't. It has no y. There is no y. Overloaded functions and methods. This one was probably the one in TypeScript that I thought was the most controversial for me. I'm like, how on earth do they do that? JavaScript does not do overloads. And as I was talking to one of my mates on the train who's just started at Canva, I said it's actually not as bad as I expected. All you're really doing is defining the shapes of your method. You're basically saying draw has these kind of two variations. The actual implementation is you still have to handle all those different variations of it. So it's actually pretty, I feel less angry about it than now that I've seen it. I was wrong. I'm sorry, TypeScript. Okay. One thing to point out here is something that's a little bit different. You know, and even after I've worked a lot with Canvas, a lot. And one thing I hadn't realized, which when you're using a type JavaScript implementation, is it will guard you against cases that you didn't even know existed. So when you've created a canvas, you've got that, yes, that's great. You get the context from the canvas, that's the thing you draw on. You've asked for the 2D context. Now, I normally just go into my code, and the next thing I'll do is start drawing mindlessly on that context. Probably a bit of lime, maybe a red circle, depends on my mood. But what will tend to happen is then I'm doing that, but the type system pulls me up. This is where any of them will pull me up and say, hey, mate, that could be, and I use mate, I'm sorry, it's that's how they talk to me in that way. I'm actually going to make Australian version compilers. No, it pulls you up and says, no, this is something that could be nullable, and you need to take care of this case. So when we're saying, okay, I've got this rect creator, because it's getting a context there, which is, let's go back. Yeah, so I've said that this is not nullable. The absence of a question mark says this thing's going to have to be required. Then I actually have to test that the context exists. And then before I can start using it in any sort of way, I have to actually do these guards. So this is where I'm guarding against these usages to make sure I actually have the thing I've said I've got. Generics in TypeScript, same thing, but many fewer words in terms of Craig's good English lessons. Enums, slight different in TypeScript. You can only have numeric enums, but for that's a bit of a here nor there. These are the things that both TypeScript and Flow have that I think are wonderful, and that's string literal types. So I think these are almost preferred for me over enum types. It's where you can say, and it's essentially a union type. And a union type means basically this thing or this thing. But what they do is they construct it out of string literals. So the spinner CSS classes can be either standard or fancy. We all know about that. And the create spinner, we've got the style, and then same thing. A bit of ES6 sugar there, saving me some characters. So these are okay, and this one fails because awesome is not a valid value for the spinner CSS class. Demo time, okay. This is where things get a bit tense. So let's check on the status with no, that's me, no. Right, got a few people, that'll do. Right, so what I'll do is I'll walk you through the code first, and what I've done, and kudos to Ben Buchanan for doing something like this way back when I think you used stage, different Git commits, and you walked through them to save you doing a demo real time and typing. Genius idea. So this is what we call the Buchanan Technique for for code demos. So what we've got here is a snippet of, or it's actually, like it's an actual working app. So this is basically where I'm saying that given a number of usernames from GitHub, I want to go to the API and fetch the avatar and then display the avatar. Because one of the main things that I'll talk about later that's a bit of a weak point with typing and JavaScript is that when you have to talk to any API endpoint that is not typed, you know, and JSON's basically one of those things that you're talking to a thing and it's numbers and strings and it, you know, it's okay, but you've got to guess. So, and this does dive into a bit of a technique that we use at Canva as well. So what I'm doing here is, and this is completely fine from Flow's perspective, so if I go into, no. That's a good mapping API, thank you, Bing. I'll just use terminal. I don't know. This button, fine. See, this is why you use the Buchanan technique, because as soon as you have to type, so essentially the command here is flow, and it'll type check your directory, project, whatnot. So flow is saying no errors, but it is showing us something else that I find a little concerning, and that is these yellow bits. So yellow, both being the color of bananas, is also the color of warnings. And it's basically saying what we don't have is we don't have coverage here. So it doesn't know what these types are. So we're guessing basically. We're beyond the realms of what Flow is saying that we have. So 79% coverage, and that's very much too small for you to read, is not good. It's okay, but if you're going to type your JavaScript, why go halfway? Like it's pretty much saying that 21% of your code is likely going to kill you. Not good odds. So what I then thought is, okay, cool, how can I move forward from this place? And using a technique that we've got at Canva, I move forward to something look like this. So what I'm doing now with my JSON is I'm taking it and I'm parsing it in using this typed JSON structure, which then looks like something like this. So, and this is where it starts to look really nice in terms of flows. And I'm sure TypeScript would do an equally good job of this. But what we're saying, actually it doesn't. I lie, it doesn't do a good job of this. We say a JSON is a string or a number or a Boolean or a null or a JSON object or a JSON array. JSON object is a map of string to JSON. I changed it from an object, I felt map was better. JSON array is an array of JSON. Lovely. This parse method does all the things to turn it into the appropriate types. So what we end up with at the end is essentially our typed JSON. So this is something that now no longer has bad coverage. Even though I can't show you nicely on that screen, I can type flow coverage. Well, that's better, 85. Now we're only at 15% that's going to kill us. So that's better, but what it has brought to the surface, how big's that? Is that big enough for people who can see the warnings? Okay, so what it is bringing to the surface is that it's saying that these things that we're now asking for are not in this thing, this type JSON thing. It doesn't know about ID, it doesn't know about name. So it's now starting to error. So we need to keep moving forward. So what I now do is I introduce this concept of a typed map checker, which is when I'm passing it a map, a JSON object. It's probably maybe not the right word in retrospect, but I'm saying I want this field and I require a number. So this is basically creating some runtime checks to say I've got this thing based on I want this field and it has to be a number when it comes back. So I say, oh no, map's right. So okay, map get me this thing. If the type of value is a number, return number, otherwise throw a type exception. Now we can have discussions about exceptions versus not using exceptions for a long time, but this is a good way to enforce the type safety. So this then says, okay, you've been given a bit of, you've got a map of type JSON, which this is, and then I'm going to pull out all of these things that exist. So let's just make sure that because I'm loving calling this the Buchanan Technique. Because the flow IDE is not made with the Buchanan Technique in mind, it starts to fall over a bit. And still, we can start to see that it's still not happy about things. Type JSON array type. So once again, it doesn't know that we've given it this is what it is. So moving forward, yep. So that demonstrates the point. Basically, it's saying type JSON could be anything. I don't know what it is, because if we remember that we've been given JSON, which could be string, a number, a boolean, null, JSON object, or JSON array, that it has no ability to assert that we've given it actually a JSON object. So we move forward from this point and we say, right, if it is an instance of map, then, and this is interesting because this is where we still are using JavaScript types to do instance of and things. We're not using these JSON object things that we've defined. Then we can do this. Now, what have we got? Yep, that's right. But we're looking pretty good in coverage. We're up to 93. So this is where we're starting to progress. Just going to zoom out for a bit. Let's play spot the changes. Ooh.
Is this the fatal flaw?
No, there's many fatal flaws. You use the singular. No, there it is. So what's happening now is that because we have, what we're saying is this fetch method, and as we've defined it up here, will return a promise of a GitHub user. So this is where it fails, is that the fetch user, and sometimes this is actually the experience you get when you're working with these tools, is you're like, what does this even mean? So I'm just demonstrating the full experience. What we've said is okay, we've got a promise of a GitHub user, but what we're doing is going, well, if typed JSON is an instance of map, then do this, but this is implicitly doing this. Which is why we're getting this. So it's basically saying, I can't do that. You don't have one of those. So, and which is resolved by this piece of code. So this is now throwing, which means that the promise cannot be resolved, or it won't be resolved with a successful case of a GitHub user. That can only be done with this case. And you'll notice that GitHub user is not a class. It's not, I don't have a new GitHub user, I don't have anything like that defining it. It's just this type GitHub user, which basically says it's going to get an ID, a name, an avatar URL, and a URL. These little pipes here mean it's an exact type in flow, which means it can't have anything extra. You know, you can't put in phone number. If you do put in phone number, it's not going to work. There you go, phone number, not there. Are we at the point where we should test this? Well, we're actually pretty good. So the thing is here that we've covered all the cases. So typing flow gives us no errors. But we've still got 93% coverage, so we're still missing a little bit. So let's just see if we can close out these last few, that's other things, these type exceptions. So we've got that. So this is where we start to put in the response. It's a type of response, it's mixed, a few other things, nothing terribly complicated there. Moving on a bit. This is where I do a bit more to say, okay, I want some more specific type checking. And like, I won't go into that too much, you can play around with the demo, but it's basically saying I've got a user type. But it is a good example of template types. So you can see that it's basically map property checker of a certain specific type of object. That's saying I want to require a number. Bit of undocumented feature magic there from Flow. But basically the ability to pass things back as specifically a GitHub user type, which should bring us to 100%. Apparently there's nothing in our code that's going to kill us, which I think brings us to a good point to test the demo. I'm trying to work out if I should test it with the breaking case that we found at Yale or not. I'm not going to. So let's go into our app file. Well, still don't have many people, that's okay. Less people, the less risk of error. No. Do you remember how I did this, Sharky? It was really good. No. That's how you can do developer mode in Atom. It's really useful. No. I'm just going to do it manually. Stuff it. Atom has a really good way of enabling you to do this. Oh, hi, Jess. I saw you there before. I just didn't say hi.
Yeah, Alex deleted my hello.
Oh, that was your hello. Do you want it back in? I'll put it back in.
I wanted to
Hello,
be
break.
first.
Oh, you want to be first? Okay, let's do that.
Break.
Well, will it?
Yes.
Will it?
Last
I know. And as Sharky's saying, it would break because the demo, yeah, it broke more than it did here. That was because what I was doing is, and I made the incorrect assumption that catching the fetch API catch would handle 404 cases. That was incorrect. It does not. It returns a status code at that point and still comes back, and then you've got to handle that. So I had to go, if it's not an OK status, return null. And you can see what I'm doing now in the promise is I'm saying, you actually maybe won't have a GitHub user. So hopefully what we'll see is it actually still work. So let's, I don't like to give too much of a level of confidence about these things. What do we got? What do we got? Oh my goodness! Wow. That worked. See, now you want to put your names in. But see, and there was no hello, was there? No. But if I was to take that clause out, I'm not going to do it. Anyway, so the demo worked mostly. Syntax flow, you've seen most of it. You can have a look at the slides afterwards. It's good. This is pretty useful, and basically this is for interacting with external APIs. TypeScript has the same thing, but one of the super cool things is these cases where you basically have an overloaded representation of an API, and it will give you the right object back. So you go create element canvas, and it'll give you HTML canvas element back. Super useful because otherwise, like in Clojure compiler's case, it'll just give you an element back because that's as much as it knows. And then you have to do the heavy lifting yourself. Liked this one. This was pretty cool. You could basically use the string or these literal types in a map as a key. I found that to be pretty awesome. Caveats. I think this is probably the most important stuff to talk about. Dealing with the browser, it's painful. No, it's hard because the browser has a mind of its own. So as one of the classic stories about when people rag on JavaScript and the varying opinions are it's not JavaScript, it's the browser. Well, let's be fair, it's both. The problem exists in both places. When you have to cross the divide to the browser, you're actually working in a typed environment. So what's happening now is actually we get a bit more parity, but it still can be a bit painful. The newer languages like Flow and TypeScript do a much better job. IO mainly input, which is why I had it part of my demo, is that anytime you're taking input into a typed environment, be that JSON, file-based input, whatever it is, you're going to have to deal with edge cases. Third-party libraries, this is probably the worst. And where TypeScript is actually strongest is they have a really good set of libraries for, they call them externs definitions, or what do they call them? Who's a TypeScript fan? What do they call them?
Like the type definitions?
Yeah, type definitions. Yeah, it's all on definitely typed as a repo, and it's massive.
It's moved to Node now.
Has it?
Yeah.
Oh yeah, they're good like that. Yeah. I liked that. And I think that's a really good, like their case of, just shows the adoption of TypeScript is well beyond a lot of other people, other techs. Feeling too comfortable with type checking? Is this a thing, Rob? Can you be too comfortable?
I can't work without it anymore.
Okay. Well, so you can't work without it, but there are things that will still slip through the cracks. And, Elm is a good example of something that does pretty much make an assertion about no runtime errors. And I think it gets really, really close. I don't think there's many things that slip through, and if they do slip through, they work out how to fix them.
Stack Overflow, seen that.
Yeah.
Type error.
Yeah, I guess they get out of it that way. Oh, we couldn't unwind the stack. All right. So just a couple of quick examples. Once again, this is the one I talked about. Third-party libraries, this is the, oh my goodness. So in Clojure compiler, this is what the definition of jQuery's attribute method function thing looks like. Who's worked with jQuery? So the thing is, jQuery is awesome. Like, when it first came out, we're always like, this is so nice. It makes everything so tasty. But the reality is it gave us a very indeterminate API, and we could do anything with it. So as soon as you try and represent what that array looks like, oh my goodness, it's just a mess. The TypeScript definition is much better because what it can do is start to represent the overloaded cases, which is where the overloading comes in pretty handy. And flow is basically exactly the same. The good thing about flow and TypeScript is once they define it in a TypeScript definition, pretty much one comes across for flow exactly the same because there's very little difference. This is a cracker. Right. This is not something you might find in another language. So we don't all know, but so JavaScript's recently gotten the new map type, and the map type's lovely. It's actually a better way to represent what we've been doing for a long time with just object literals, but it has a different way of operating with it. So we make a new map. We set these two keys, one, two. Yep, great. So this is what reading keys looks like from a map correctly. You don't do object keys on a map. If you do, you get an empty array. Little surprising, but that's what happens. Now, from a perspective of the type signature is right because object keys accepts an object, and map is just an object. So there's no type check way around this. There's no ESLint way around this. If you could use the combination, you might get around it. So as I said, basically you won't get a compiler, you won't get an exception. You'll just get, like, if in your code you're using this and you're expecting to get a list of keys back on which you're going to iterate, you're just going to end up with nothing, and it's going to be dumb. So just be aware. And it's just one that we recently came across at work, and we're like, how do we get around this? We don't know. A few stats, I'll let you read them later. Pros. Clojure compiler is really solid. I think it's very good for us at Canva, but the more I work with Flow, the more I like Flow, and I probably will try and make a compelling case for us to move to it sometime in the future, but it would be a big job. One of the big cons with Clojure compiler is this type inference technique is just pretty broken. I was going to use a different Australian word. But it is really broken. They're transitioning between what they call OTI and NTI. Can anyone have a guess at what they think they might be? Older type inference and new type inference. The Clojure compiler people aren't very imaginative. TypeScript, look, it's like the best thing you could use now. If you said, look, I really want to use some sort of type system in my JavaScript, what should I use? I would be lying if I said you should use Flow now. You should probably use TypeScript. And that's one of the main reasons, is that you could move through a fairly simple migration path to Flow once it hits a level of maturity. There's some weird things it does, but let's pretend it doesn't. Just don't do that. Like there would actually be a legitimate case for our best bits of TypeScript, or the best parts of TypeScript book, Crockford-esque type things. So someone cranky making a book. Flow, really, really like it. One of the big things I do like about Flow is it doesn't force you into something that feels either object-oriented or functional. It lets you choose, whereas TypeScript, I think, does coerce you down an OO path. It's saying, come this way, extend things, implement interfaces. Maybe it doesn't, I don't know. But it's the way it looked like to me. This is a very personal opinion. The fact that it's developed in OCaml, I think it shows a lot of promise. Facebook are putting a lot of effort, and they've done a lot with OCaml. They've got very smart people working on all their tech. They've got Hack, which is type PHP. They've got another thing called Reason, which is OCaml with a nice syntax.
And build system.
And build, yeah, they're just doing so much stuff. So I think what we'll see is just the sheer volume of people working on this turn Flow into just a piece of tech that will just all be like, remember how we weren't sure which one to choose? Yeah, can't believe those days even existed. Yeah, at the moment there's a few things, but you can get around them. But it's still a bit early. Recommendations, oh yeah. What's the right word? Don't chicken out. Each of these tools tries to give you a really nice onboarding experience and tries to let you get away with as much JavaScripty badness as you've been doing in the past. Turn the no badness options on. So in Clojure Compiler it looks like this, TypeScript it looks like this, and as I was talking to Rob before, apparently TypeScript 1 was quite vicious, and TypeScript 2 is a lot friendlier. Make TypeScript 2 like TypeScript 1, make it vicious. And Flow, yeah, it's really the coverage is the only tool you've got. Explore the options, have a play. My opinions, you've heard them. Slides are all online. Probably the right way to experience the different syntaxes. Yeah, that's it.
I'll just get this and I'll race straight down to Rob, shall I?
Rob's got no questions. It means it was an excellent presentation. Someone else first. It just, it'll save me the embarrassment.
When do these type systems integrate into your workflow? Say, do you use Maple to interpret or
That's a really good question. That's one of the main differentiating factors between the tools. So it's probably a big factor. That I don't have that in the talk is probably a bad thing. So Flow is essentially it's just called a static type checker. So it does the only job it has is to look at your code and report as to where the types are, where the types aren't, where you can trust it, where you can't trust it, and it does. It purely integrates into a flow like Babel, whatever it's called. And basically what you do is you run let me see if I can even pull it up. It probably can. Your Babel configuration looks pretty, man. All you're doing is you're using these couple of transforms where you're saying this transforms flow strip type. So what it does at the end of that is part of the process is just ripping all the type information out and then passing it on to do the extra transpilation. So it doesn't try to do that, whereas both TypeScript and Clojure Compiler use a compile step. So one of the nice things, because Flow is quite lightweight in that regard, you can get the information back in your editor quite quickly, which is not something we have the advantage of using Clojure Compiler. Clojure Compiler is written in Java, so tends to work pretty slowly. And I think TypeScript's quite quick too.
Yeah, it's pretty much the same.
Yep.
I was going to ask a question as well. So you mentioned that there's similarity between TypeScript and Flow in terms of syntax.
Yep, I think so.
In terms of, so I've tried to implement Clojure Compiler with my TypeScript Angular 2 stuff.
Yeah, I've heard of people doing that.
The advanced compilation doesn't work particularly well.
No.
Do you know if there's a way to output Clojure like valid code from TypeScript or Flow?
So one of the things I was talking to my colleague on the train about, one of the migration paths that I might consider trying to do at Canva is to take, because Flow has all that type information, I think you can print an AST of all that information, is actually generating the Clojure compiler friendly comments and actually injecting it into the code. So it's kind of the reversal. It's strip types but also inject Clojure comments so it can be compiled. I don't know of anything existing yet, but that's what I was thinking about. I know that issue you're talking about because I found that issue on, I think it's on Clojure compiler or Angular, but on one of the repos has got that specific case.
Yeah.
And one of the things about Clojure compiler is its advanced compilations are quite amazing in terms of what it can, dead code analysis, rips it all out. It's very, very good.
We had savings of like 50% on Clojure compiler.
Yeah, so
just standard.
So if you didn't hear, it was 50% savings, and that's not even in the New Year's sale. That's just all the time.
One more question, or Damon's going to give you another day joke.
Hey, you mentioned good editor support for Flow.
Yep.
What are you using?
I'm using Adam here, and I'll plug in Euclid, the Facebook thing, and I have changed that since the hour presentation too. There are quite a few plugins, but definitely the Euclid, or I don't know how it's pronounced, that seems to be the one that's best.
That would be really slow.
Well, I've got a pretty powerful machine, so.
Can we please thank Damon for his time?